Hello and welcome to this video in the R Analytics course by White Knight Ventures. In this video, we will be looking at the dplyr package. What does the dplyr package do? The dplyr package helps us transform and manipulate data so that we can summarize these data sets and get some inference out of the data that is there at hand. For example, you might have a large data set with thousands of columns, rows, etc. But not all the time do you require all the variables and all the rows in a particular data set when you're analyzing them. You might be requiring, say for example, you might be having data sets of insurance policy holders and you might be requiring to just analyze the number of claims you're getting from a smoker person, a person who smokes in your life insurance company. So you might want to extract the data for the smokers only from all the policyholders data set and then draw your analysis on that. So in such a situation, the dplyr package comes in handy because it helps us manipulate the existing data to convert it into a data which will be of relevance to us and then help us conduct analysis on it. Clear? But first and foremost, we must install and activate this package. We have already seen various ways of installing a particular package in R and then activating it using the library command. I hope all of you have done this. This is the data set that we will be using. It is an Excel file that I will be importing, which has 7 variables and 153 observations. The variables are month, dealer, sales manager, item, quantity, unit cost and amount. So let me go to R and then first import this data for me and activate the dplyr package. Clear? So you can see here that the data that I have imported also has 153 observations and the same 7 variables as shown earlier. The various functions in the dplyr package that we are going to have a look at in R are these: select, filter, arrange, distinct, mutate, transmute, group by, summarize, the pipe operator, slice and count. The pipe operator over here, however, does not belong to the dplyr package per se, but the functionality that it has helps us use various functions in the dplyr package. That is why I have put it over here. Let us go to the first function in the dplyr package called select. Select function keeps only those variables or columns that you want to retain or extract. For example, the table that we have imported over here has 7 columns. Alright, what if I want to extract only sales manager, item and amount? Sales manager, item and amount for some analytical purpose. So I want only 3 of these variables from the 7 variables that are there in the original data set. So the select functionality can help us extract these 3 variables or these 3 columns and create a different data set altogether for our analytical purpose. The syntax for the select functionality is this: select, open brackets. In the first argument, we pass the name of the data set where this particular table is saved. Please remember that all the functions that we will see in the dplyr package will have the dataset's name as its first argument. Always. Be it select, filter, arrange, mutate, transmute, whichever function you want to use, all the functions in the dplyr package have the dataset's name as its first argument. The second argument over here is, you can see column 1, column 2, ... I have put it in square brackets is because it's not necessary to pass these, all these arguments. You might just want to extract one column, so you pass the name of the first column. You might want to extract the second column also, you pass the name of the second column, so on and so forth. Clear? Let us look at some examples for more clarity. Suppose I want to select columns month, dealer, item and quantity. Month, dealer, item and quantity. So what I will write is, I'll write select, the name of the data set, which is sales, and then the name of the variables that I want to extract. Please remember, when we are writing the name of these variables, it should be exactly the same way as it is written over here in the table. So here, if I have written quantity as QTY with Q as capital, then I need to write QTY with Q capital over here also. And now when I press Ctrl Enter, you will see that we have a table with 153 observations because all the rows are coming in, but only 4 variables. And those variables are month, dealer, item and quantity. Here. select columns from month to quantity. That is, you need to select month, dealer, sales manager, item and quantity. So it's a sequence in which it is arranged. All the columns from month to quantity need to be extracted. So one way is to write select the name of the data set, comma month, comma dealer, comma sales manager, comma item, comma quantity. And another short way is to write month to quantity. Month to quantity. What this will do is it will extract all the columns from month to quantity, which are 5 of them. Clear? Next, deselect the column month from the data set. So you want to select all the columns but the column month. So one way is to write select name of the data set and all these things, dealer to amount. The other way is to write select sales and then minus month. Minus month means that give me all the variables in the sales data set apart from month. Apart from month. So it has given me 6 variables, you can see. It has extracted the first one, which is month. Next, select columns ending with the letter R. Sometimes you would be unsure of the full name by which you have saved a particular variable or named a particular variable. But you know that that particular variable ends with the letter R. So what you can do is that you say this to R, that select all the columns which have the variable name ending with R. So in this case, we use some enablers or helpers within the select function. I would try to show this to you. We write sales and then there are certain, see, ends with. Ends with is in dplyr. It determines if entries of X start or end with a particular string, prefix or suffix respectively. So we can have starts with also, we can have ends with also. Clear? Ends with and ends with the letter what? R. The moment I press enter, you will see dealer and sales manager. Dealer and sales manager are the only 2 columns which end with the letter R. Clear? You can see it here also when I write select. When I write select and when I press this, you can see the various enablers that it gives you. So when I write ends with, it gives me. Okay, now when I scroll down, you will see various things that it is trying to explain what the ends with command does for me. Clear? See, ends with, these functions allow you to select variables based on their names. You have starts with, ends with, contains, matches, num range, one of, everything and last call. So these are various enablers that the select functionality has within itself to help us extract columns from a particular data set. Alright. Next, select columns containing the letter R. Now, what I'm saying here is that it will have the letter R. It need not end with it. It might not start with it. It might be in the middle. It might be anywhere, but it has the letter R in it. It has the letter R in it. The moment I press enter, you see again dealer and sales manager. You can see month does not have R, item does not have R, quantity does not have R, unit cost does not have R. For example, I change this to T. Let us try this with T. Contains the letter T and I press enter. You'll see month, item, quantity, unit cost, amount. So no matter where T is situated in the name of the variable, if it contains the letter T, it will give you the name of that variable. Select columns starting the series M. Starting the series M. So here we write select sales and we use the thing matches. See, it is not starting the name, it is starting the series. I'll give you the difference. Do not miss out on this dot. M dot means that it starts with M and there is something after M. There is something after M. So see this. It gives you month. So it is starting with the letter M, but it gives you sales manager also. It is not starting with M, but there is a series within the name of the variable which is starting with M and there is something after M. Similarly, amount means there is an M and there is something after M also. So basically what matches does is that it will give you the names of the variables which have the letter M in it, and after M there is something in that particular name of the variable. It will not give you anything that ends with M. So anything that does not end with M but has an M will be extracted by this methodology. Select columns with multiple variables. So we write select sales one underscore of month or dealer. So any variable which has month or dealer will be extracted over here. In our case, it is just month. Clear? Lastly, we have starts with the letter D. This is self-explanatory. It will give me those variables which start with the letter D. In our case, it's just dealer. Clear? So the select functionality helps us select or keep only those variables or columns that we want to extract or retain from a given data set. Alright. Next, filter. Filter does exactly the same thing as select does. However, filter does it for rows, select does it for columns. Select helps you retain or extract certain columns. Filter helps you retain or extract certain rows. And the syntax goes as this: filter. First argument, as already mentioned, will be the name of the data set. And the second argument is the criteria based on which you want to filter the rows. So for example, if we have a data set here, say I want to extract all the data only for the month January. So then I will put a criteria that those rows which have month as January should be retained, rest of them should be removed. Or for example, we want the rows for SK Enterprises. Then we will write filter all the rows in sales data set on the basis of the fact that it has dealer as SK Enterprises. Clear? So let us again look at some examples. Filter only those rows where item is pen. So we write filter, the name of the data set sales, and then we put item equal to pen. Please remember why we are writing double equal to is because we are trying to find out the relationship and not using it as an assignment operator. So wherever item is pen, it will extract those rows for me and all the columns, mind you, all the columns. So see, you have all the columns, 7 columns, and 18 such rows have pen in it. 18 such rows have item equal to pen in them. Alright, next. Quantity is more than 50. Quantity is more than 50. So you want to extract all the columns but only for those rows where quantity is greater than 50. So my criteria changes to QTY greater than 50. QTY greater than 50. You can see we have 88 such cases out of 153 where the quantity was more than 150. Sorry, 50. Next, item is pencil and quantity is more than 50. So you have two criteria to be met. That item should be pencil and the quantity also should be greater than 50. So here we will use the AND operator. AND operator. How will we use this? We will say that go to sales, and in this, where item is pencil and quantity is greater than 50, extract those rows for me. Extract those rows for me where item is pencil and quantity is greater than 50. You can see that there are 27 such cases where item is pencil and quantity is greater than 50. Clear? Next up, quantity is between 50 and 80. So you can again use the AND operator, writing quantity greater than 50 and quantity lesser than 80. And lastly, item is pencil or quantity is more than 50. So here it's not an AND condition, it's not an intersection, it is an OR condition. So we will write sales comma item equal to pencil, use the OR operator which is the pipe, quantity greater than 50. So obviously in this case you will get more number of rows than what you got in the AND operator. You have 109 rows where either the item was pencil or the quantity was greater than 50. Select and filter. As mentioned earlier when I had introduced the various functions to you in the dplyr package, I told you that these functions can be used individually. However, most of the times when we have certain cases to solve, we will use them together. So let us see how we can use the select and filter functionality together in order to solve a certain scenario. The scenario at hand is we want to extract the sales manager, item and quantity, but only for the item pencil. We want to extract the columns sales manager, item and quantity, but only for pencil. So how we do it here is, the first method is I create a new data set K. I create a new data set K in which I select the variables sales manager, item and quantity from the original data set sales. So from the original data set sales, I have extracted 1, 2 and 3 columns and I have saved this in a data set K. Then I go to dataset K and filter it. So I filter K on the basis that item should be equal to pencil. Item should be equal to pencil. So see, when I write K and I execute K, it will give me 153 rows with 3 columns, and the columns are sales manager and item and quantity. And then in this also what I do is I tell R that in K also just keep those which have item equal to pencil. So I get 48 such rows where item was pencil and the 3 columns sales manager, item and quantity. So in this what I did is I broke the sum into 2 parts. First I selected the columns, then I filtered the rows. The other way could be to do it in one go, that is by nesting of functions. Nesting of functions, clear? So in nesting of functions, how it works in R is that you can see here I have used the function select, and then within the function select I have used the function filter. So as the Bodmer's rule goes, we will first solve, or we will first perform the functions within the brackets, and then the functions outside the brackets will be performed. So first the filter functionality will be performed. The output of the filter functionality will become the first argument of the select functionality. You can see here that when I write select and I open the bracket, instead of passing the first argument, I am passing the filter function, and then I press comma. So before the comma, you will get the output of the filter function, which becomes the first argument for the select functionality, and then the second, third and fourth argument are the names of the columns. So what is happening here is, first we are filtering the sales data with respect to item equal to pencil. So the data set that will come out over here is the sales data with all the columns, but only those rows where item is pencil. And then we will select from this data set only the 3 columns sales manager, item and quantity, so that the end product has only those rows where item is pencil and only those columns which are sales manager, item and quantity. So you can see here we got 48 rows with 3 columns. If I perform the functionality in the same manner, I'll again get 48 rows and 3 columns. First I filtered, then I selected. Earlier I had selected first and then I had filtered. So the output will not change in this scenario. The output will not change in this scenario. It's just that I have changed the order of performing the functions. First I have filtered, then I have selected. Previously I had first selected, then I had filtered. We can also do it the other way. We can first select. What are we doing? We are selecting from sales the 3 columns, sales manager, item and quantity. Alright. So the output of this function will be another data set which will have only 3 columns, sales manager, item and quantity. Now on the output of this function, which is another data set with only 3 variables, that will be used to filter the data where item is equal to pencil. And again the output will be the same, 48 rows and 3 columns. So this is a situation where whether I select first or filter first, it will not alter my answer. It will not alter my answer. You can feel free to break the situation into 2 parts and then solve it like I did in the first method, or in the second method where I have nested the functions together. Clear? Please remember, when you're nesting the functions you want to perform first should be within the brackets, and the functions you want to perform afterwards should be outside the brackets. Clear? So see, whether I use this method or this method, all of them will give me the same answer in this scenario. But is it always the same case? Is it always that whether I use select first or filter first, it will not affect my answer? It will not affect my output? It might not be so. Let us look at this case. We want to extract month, dealer, we want to extract for the month of May, dealer, item and quantity. So the columns or the variables are dealer, item and quantity. However, the filter is on the basis of month being May. So the last or the final output will have only 3 columns, dealer, item and quantity. It will not have the variable month, remember. It will only have the variables dealer, item and quantity. However, the dealer, item and quantity that I have extracted in my final data set all pertain to only one month, which is May. So in this case, we need to filter the data first. We need to filter the data first on the basis of month being May, and then select these three columns out of which are dealer, item and quantity. If we select these first, and put it another data set like this, suppose I select these first, sales, dealer, item, quantity. All right. So I write select from the sales data set, dealer, item and quantity. Now remember, the output of this will be the input for the filter function. Remember, output of this function will be the input for the filter function. And what will be the output of this function? The output of this function will be a data set with all the rows and only three columns, dealer, item and quantity. So I write this. See, you get the error object month not found, because obviously when I select sales, dealer, item and quantity and I execute it, this is the table I will get. Now where is the month May? Where is the month variable? It is not there. And then I'm telling R that filter on the variable month equal to May. Obviously this will not happen because I have selected only three columns and those columns do not have the column month in it. So how will I filter this data set? That is why it becomes essential for us to first filter the data in this case and then select it. First filter and then select. Alright. So the order over here matters a lot. In case you forget to do that, in case you still go ahead and select first, then you will have to tell R that go back to the sales variable, sales data set, and in that go to the month variable and use the month May. Alright. So either you do it the logical way where you filter first and then select. But however, if you have selected first and then also you want to filter on the basis of a variable which is not available in the new data set, then give reference to the old or the original data set and use the filter functionality. Clear? You can see here, if I press this, I get four rows of three variables. 4 rows of 3 variables. Clear? Next function, arrange. As the name suggests, it will help you arrange, order or sort the records, that is the rows, based on the variables. Clear? So you tell R on the basis of which variable do you want to arrange your data set. That is it. That is what the arrange functionality does. By default, the arrange functionality will always sort the data in arranging order. It will always sort the data in arranging order. Clear? The functionality goes as this, or the syntax goes as this: arrange, first argument being name of the data set, second argument being the column on the basis of which you want to arrange. But why do we have then column 2 and dot 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 dot, which means we can have more columns over here? What this means is that first the data set will be arranged on the basis of column 1, then within that it will be arranged on the basis of column 2, then column 3, column 4, so on and so forth, as many times you want to arrange it. So for example, you say arrange on the basis of quantity. So it will be arranged on the basis of quantity in the ascending order from the lowest to the highest. Clear? Lowest to the highest. And then I say also arrange on the basis of unit cost. Then it will also arrange that data set which has been already arranged on the basis of quantity on the basis of unit cost as well. We will look at a couple of examples which will give you more clarity. For example, sort the data set based on months. So we write arrange, name of the data set and the name of the variable which is month. You can see it has arranged it from A to Z. Now I say that sort it on the basis of month and dealer both. Sort it on the basis of month and dealer both. Now before I execute this, see, for April you have dealer Gupta, 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 modern, modern, and for August you have modern, Vishnu, Vishnu. Okay, so on and so forth. This way it is going on. The moment I arrange this now what this will do is, let us save this first. Let us save it in K and let us save this in M, suppose. When you view K, you will see this. For December, you have modern agencies twice, then you have Narayana traders, then you have Vishnu, then you have SK. So you can see that within dealer, it is not arranged from A to Z. It is just the column month which has been arranged to A to Z. Clear? Now when I have written month and dealer both, so what it will do is it will first arrange month from A to Z, based on which the whole table will be arranged, and then within April for month, dealer will be arranged from A to Z. For December month, dealers will be arranged from A to Z. For January month, dealers will be arranged from A to Z. So when I look at M and I go to December month again, you will see first is Saurav, first is Gupta, then you have Modern, then Narayana, then SK, then Vishnu. You can see this is not the same order as you could see here. In row 10 you had Narayana, in row 11 you had Vishnu. Here in row 10 and 11 you have just Gupta. So what this is doing is basically it is arranging the whole table on the basis of month first, going from A to Z. Then within the month, within a particular month, it is arranging the dealer from A to Z. Alright. So it will first arrange on the basis of the first column mentioned over here, then on the basis of the second column. Clear? Next, arrange the data in descending order of quantity. In descending order of quantity. So for descending, we have to write DESC, and in brackets we give the name of the variable on the basis of which we want to sort the data. So I write arrange sales descending quantity. You can see this is the highest quantity, and as we go down it keeps on decreasing as we have arranged it in the descending order. Next is distinct. Again, as the name suggests, it will help us extract unique values from a variable. The syntax for the distinct function is, again, name of the data set, comma, which column from which you want to extract the values. So I write, find the names of the dealers. So if you can see here in the original data set, you will see there are various dealers over here, but you see the names of the dealers are being repeated. So I want to find out exactly how many dealers we have and which are the dealers. So when I write this, we have only 5 dealers, which are SK Enterprises, Narayana Traders, Vishu Stationery, Gupta Book Depot, and Modern Agencies. These are the 5 distinct dealers that are there in the data set. Find the items sold by each dealer. Find the items sold by each dealer. So I write distinct sales dealer item. So before we do this, let us see what this does. Distinct sales dealer item. What this will do is it will give me unique combinations of dealer and item. It will give me unique combinations of dealer and item. Gupta Book Depot pen, Gupta Book Depot pencil, Modern Agencies pencil, Modern Agencies binder, Narayana Traders pen, Vishu Traders pen set. So there will be no combination which will be repeated. It will give me unique combinations of the dealer and item. And then if I arrange this by dealer, now you can see clearly that Gupta Book Depot sells pen, pencil, binder and pen set. Modern agencies sell pencil, binder, pen set, pen. Narayana sells only binder, pen and pen set. SK Enterprises sell pencil, pen set, pen, binder, all 4. And Vishu Traders also sell pencil, pen set, binder, but it also sells duster. Alright. So again, I have used the arrange and distinct functionality together. What I did was, first I chose the distinct function in which I picked out the unique combinations of dealer and item, because I wanted to find out each and every item that a particular dealer sells. And then I arranged this data set on the basis of dealers so that the dealers come together. All Gupta Book Depot records come together, all Vishu Traders, Vishu Stationery come together, all SK Enterprises come together, so that I can see for each and every dealer which are the items they are actually selling for me. Clear? Mutate. Mutate function adds a new variable to the existing data set. Simple. It adds a new variable to the existing data set. In our data structures video, we had seen that in an existing data frame, how we can add a new variable using the $sign. That is exactly the same thing that the mutate function does for us. The function syntax goes like this. Mutate, the name of the data set to which you want to add the new variable to, comma, the name of the new column and the criteria on the basis of which the values in that new column should be installed. Clear? So for example, add a new column target where it is twice of the quantity. add a new column target. So we have 7 variables right now. If I add another variable, it will be the 8th variable. The name of the variable will be target and it will be twice of quantity. It will be twice of quantity. So I write mutate in sales. The name of the new variable will be target and the criteria will be, it will be twice of quantity. It will be twice of quantity. So you can see quantity is 95, 50, 15 and then your target variable that is added over here. So let me just make a new variable for this T and you can see we have 8 variables. Here when you go, it is 190, 95 into 2, 50 into 2, 15 into 2, 27 into 2 and so on and so forth. Clear? So this is how the mutate function works. It adds a new column to the existing data set. Transmute. Transmute column also creates a new variable, but it does not add to the existing ones. It actually removes all the existing ones. So it gives you only the new column which has been added. The functionality remains the same, the syntax remains the same. So if I write transmute sales target is equal to 2 into quantity, you will see it will just give you the new column which has been added. It will not give you the old columns. It will not give you the old columns. Clear? Group by. It helps creates groups in a data set based on a particular variable. Very simple. So if I want to create groups of dealers together or items together or month together, it will help you do that in R. It is however useful mostly when it is used with other functions. Standalone, it does not give you any sensible output. So the syntax goes as group by name of the data set, the column on the basis of which you want to group first, then second, then third and so on and so forth. You can also ungroup the data set by writing the ungroup function. So here, create groups in the data set based on items. Create groups on the data set based on items. So see this. I write group by sales, comma, item and it does this. Obviously, this is not making much sense. If I say that I have grouped the data on the basis of items, what you can vision is that you will have pencils together, binders together, pens together, etc. And it will give you how many pencils it sold, how many pens it sold, or what were the amounts it could earn, etc. But nothing of that sort is happening over here. Nothing of that sort. So what I do here is that we try to get the maximum units sold for each item. We try to get the maximum units sold for each item. So I write filter group by and that grouping is done by item and then I write quantity as max quantity. The filter should be done on the basis of max quantity. Now if you see, we have for January pen was sold 120, again pen was sold 120, duster 110 and so on and so forth. We have 5 rows and 8 columns. Clear? Alright. Again, this is not making much sense. It is not giving us the desired output that one was looking for. So let us first look at one more function that we are left with and then I will come back to the group by function along with that function. Clear? So the next function is the summarize function. This helps us generate a single statistic or number for the data set which gives us an idea. Like we were trying to find out the maximum quantity sold or the total amount generated through the sale of pens or the total amount generated by a particular dealer or a particular sales manager. Then the summarize function helps you. And summarize function along with the group function then helps us find out a lot of data, a lot of statistics from a particular data set which we can then draw inferences out of. Clear? So the syntax for this is summarize, name of the data set, the new variable or statistic that you want to find out and the function that will be implemented to find out this particular statistic. Example, total number of units sold across all items. Total number of units sold across all items. The function goes like this. Summarize sales, where you create a new variable total and you put total equal to sum of quantity. You put total equal to sum of quantity. So what this will do is it will go to the data set sales and then it will summarize the quantity variable and put it as the total. And you will see that in total there were 8754 units sold of all the items. 8754 units sold for all the items. Now, total number of units sold and the total amount generated from all the items. So you can have n number of new variables that you can create over here. So see, sales Total quantity is sum of quantity and total amount is sum of amount. So when I execute this function, it tells me total of 8754 units were sold and this was the amount generated, 1,52,564. Total number of records in the data set. Total number of records in the data set can be found using the n function. N open close bracket helps you count the total number of records, that is 153, which is given over here as well. Clear? Get the total number of records, quantity sold and amount for each item. Now this is where grouping comes in. You have to first group the data set on the basis of item and then summarize this grouped data set to find out the total number of records for each item, total quantity sold for each item and total amount generated for each item. So I write summarize. Within summarize, I will first group the data set on the basis of item. So again, we are nesting two functions, summarize and group by, where group by will be performed first. The output of group by will be used as an input for summarize. The output of group by will be used as an input for summarize. So group by sales on the basis of item and then summarize it by giving me the count of number of rows, unit quantity and total amount. Clear? So I execute this and you see we get the desired output that we were trying to get when we were using the group by function individually. So you see 53 times binder has been, binder was there in our data set, 10 times duster, 18 times pen, 24 times pen set, 48 times pencil. If you add this up, this will come out to be 153. This is the total number of units sold. Again, if you add these up, it will come out to be 8754 and this is the total amount from each item that we have generated. If we add this up, we get 1,52,564. Clear? Every statistic for each dealer and their respective items can also be found out. So here what we will do is we will group by dealer and item both. Unique combinations of dealer and item. So A dealer has sold these many pens and generated this much amount. B dealer has sold these many pen and pencil and this much amount, so on and so forth. So when I execute this, you can see that modern agencies sold binder. These were the number of units. This was the total amount generated. Clear? These were the number of units. This was the total amount generated. These are the number of times this particular combination of dealer and item was observed in our data set. Narayana Traders binder 17 times. SK Enterprises pencil 11 times with 582 units and 1045 amount. Clear? This is how you use summarize and group by function together. Let us look at some interesting cases and we try to solve it by nesting many functions together. First, we want to extract the top 6 records for dealers who have sold the item pen only. We want to extract the top 6 records for dealers who have sold the item pen only. So what I do is I first filter the whole data set. On the basis of item being pen. So now the new data set that I have, only has the item pen in it. Then I select item, dealer and quantity from this data set. Then I select item, dealer and quantity from this data set. Clear? Then I arrange this data set by dealer. And then finally I use the head functionality which will give me the top 6 rows. So see, I started by filtering the data set with item equal to pen. Then I selected 3 columns from it, item, dealer and quantity. And then I arranged it by dealer and finally I took out the first 6 rows using the head functionality. This is how you nest functions in R. Clear? I would request you guys to practice through this method and once you guys have practiced enough, then you can write the code in one go as well. Clear? Another case. We want the maximum quantity for dealer and item combination for the month of May with just dealer, item and quantity variables. So you do not need any other variables. You just want the 3 variables, dealer, item and quantity. And in the data set, you want the maximum quantity of dealer and item combination for the month of May. So first things first, we select dealer, item and quantity. Then we filter on the basis of month being equal to May. You could have done it the other way around also. You could have first filtered on the month of May and then selected dealer, item and quantity. Remember, if I am doing it in this order, selecting first, then filtering, then in my filter criteria, I need to refer to the original data set. If you do it the other way around, then this issue will not arise. So now my data set has only 3 variables, dealer, item and quantity, and all of them are for the month of May. Now I want to find out the maximum quantity of dealer and item. For that I have to group my data first. Group it by unique combinations of dealer and item. Unique combinations of dealer and item. So see, I have taken unique combinations of dealer and item, and then I use the function of summarize and I write max of quantity. So it will give me the max of quantity for each and every item dealer, for each and every item and dealer. Clear? This is how you perform various functions of R together. One another way, if you are uncomfortable or not very happy with the way nesting is done, another way to do that is by using the pipe operator. Pipe operator. What it does is that, as I said, before we go ahead, as I said, it does not belong to the dplyr package. It belongs to the magritar package. And what does is that it helps us structure the sequence of operations in a single code from left to right. It avoids the nesting functionality. It tells you, fine, if you're not comfortable with nesting, what we will do is we will string all the functions together and it will perform the functions from left to right. So the functions you want to perform first have to be on the left and then it goes on to the right. Clear? The operator is percentage greater than percentage. Percentage greater than percentage. Example. Again, we will use the same example that we just saw. We want to extract the top 6 records from dealers who have sold the item pen only. So what I do is I first attach the dataset sales, because this is the dataset on the basis of which the whole function is going to be performed. So that again and again when I write different functions of the dplyr package, I don't need to specify that you have to go to the sales package, sales dataset. All right. So I write sales. And to link it to the function, I use the pipe operator percentage greater than percentage. Then in the sales dataset, I perform my filter function. Remember over there also we first filtered the data on the basis of item being pen. So from sales, we have filtered the data to be item equal to pen. Then again we use the pipe operator and select dealer, item and quantity from this filtered data. Fine. So after this is performed, we have a data set which had been filtered on the basis of item being pen, and it has only 3 columns, dealer, item and quantity in it. Then again we use the pipe operator to arrange this new data on the basis of dealer. And then finally we again use the pipe operator and use the head functionality to get the top 6 rows of this particular data set. Clear? So it is the same thing that the nesting function was doing, but nesting can sometimes look a little overwhelming or a little more daunting. Pipe operator on the other hand avoids the nesting of functions, and it simply tells you to string the functions in the particular sequence using the operator. We can do the second one also in the same manner. Sales, pipe operator, first selecting, then filtering, then grouping and then summarizing. Clear? All right. Slice function. We saw the filter function a while ago, which was helping us filter the rows. So if you wanted to extract some rows out of the particular data set, then you could use the filter function. But the filter function was extracting or retaining rows on the basis of some criteria. What if I wanted to extract the first 5 rows or 10th to the 20th row or the last 15 rows? If I want to filter the data on the position, on the basis of the position of the rows rather than a particular criteria, then I use the slice functionality. It helps us extract rows based on their position. The function syntax is very simple, name of the data set and the number of row numbers you want. Clear? So we write select first 10 rows, sales, comma 1 to 10. 1 to 10. So if you see here, okay, before I go ahead, I would want to show you this nesting function. You're getting 6 rows, 3 columns, and here also you'll get 6 rows and 3 columns. Okay. First 10, you get the first 10. If you want say 15 to 100, you will get the columns 15 to 100. All right. So slice basically slices the data set across rows based on the position of the rows that you're asking it to be done. All right. So see 15 to 20 and so on and so forth. Count. As the name suggests, it will count the number of times a particular value has appeared in a variable. So for example, if you saw we had only 5 dealers, but we have 153 observations. So how many times a particular dealer has appeared in the data set? We had around 5 or 6 items, but 153 observations. So how many times a particular item has appeared in the data set? Clear? So the function goes as this. It gives you the count by putting the first argument as data set, then the columns under which you want the count to happen. So count the number of times each dealer has appeared. Count the number of times each dealer has appeared. So I write count. So you can see Gupta Book Depot appeared 23 times, Modern Agency 45 times, Vishu Stationery 37 times, and so on and so forth. Similarly, I can do it for item. Pen appeared 18 times, duster appeared 10 times, pencil appeared 48 times, and so on and so forth. If you want only the count of a particular item, you can see it is 18. 18 times there was pen, 135 times there was something other than pen, false and true. Alright, this is how the count function works. This is it for the dplyr package. I would urge you guys to practice the dplyr package as much as possible. It is one of the most important packages being used in R for data manipulation. Thank you.